Hey y'all, this is a video about writing equations for lines, and made a little blank Google Doc here. I'm going to call this writing equations of lines. And you have already learned how to do that in some math class or other, so I'm going to add physics because the rules are a little different here. I mean, a line is still a straight line, but we need to have make sure that we are putting in the detail that we need so that our equations for lines are meaningful, that they mean something for the world of that our equations are trying to describe. All right, so what I did here, let me get a little smaller. I just made up some numbers here and made a couple little data sets that I put into Logger Pro. This, if I had done it in Graphical Analysis 4, it would look very similar to this. So I'm going to go ahead and hide the data set. You can see that. These are artificially nice numbers, which just means they really perfectly line up to be a straight line. A lot of the time when we collect all of the time, most of the time, when we collect data, it's not going to be perfect. It might look very much like a linear, like a straight line, but it'll be points a little bit off here and there. And I just made up some numbers, so they're real nice. All right, so what's going on in this graph? Let's just look at it for a minute. We look at the title. It's force versus position. That's force here versus position. So this is a situation where the position of something, when that position changes, this is the independent variable. When this position changes, it causes this force to change as a response to that. All right, so what could this be? Well, if you have a spring and you stretch a spring out, the amount of force that the spring resists with is going to increase with the amount that you stretch the spring. And it works backwards for a spring too. If you press on a spring, it wants to spring out back to its full length. So that's what I had in mind here. This is something that we'll look at much later in the year. We'll look at force versus position graphs for springs. And this is kind of what they look like. All right. So it definitely looks pretty linear. Everything, it looks like that whoever made this graph, it was me, attended to all the details. Here's a nice title. We got the units here and everything looks good. And it certainly looks linear. So I'm going to go up to the linear fit button and I'm going to click on that. All right. And because of the size of my graph, and I'm going to cut and paste this in a minute into my little Google Doc here. So I'm going to go ahead and right click on this little box and go to linear fit options. And I would like to change the appearance. Basically, I just want to make this box look bigger. So I'm going to click on appearance. And I'm going to go and just blow this sucker up by increasing the font. You can increase the font size. Okay. In Graphical Analysis 4, I'm not sure exactly what that's going to look like. So I'll have to do that in another video when I'm looking at some other problem. So if you're doing this on Graphical Analysis 4, then you don't have to do this, but for lab reports and things like this, we'll try to figure out a way to make it nice and readable for your audience. So I'm going to go ahead and snip this. I'm going to go over here and I'm looking for, in my programs, the snipping tool. If you're using a, let's see, does the Chromebook have the snipping tool? In different types of computers, I think Chromebooks are different. I think on a Mac, it's like Command-Shift-4 or something to get the screen snip. But all you have to do is look up on the internet, how do I do a screen snip on or with a Chromebook or with a Mac or whatever you're using and follow the directions there. If you have trouble with that, let me know and I can help you figure it out. So I typed in snip here on this Windows device. There's my snipping tool. And go to new. And I'm going to move my crosshairs up to the top of this graph here. And I'm going to drag and highlight all of this. And it automatically, I can go here and click edit copy, but it's actually already copied. So if I go into my Google Doc right here and I do Control V, or you could also go edit paste, either one, there's my graph. Boom, just like that. All right, so now I would like to write the equation for this line. And if you're thinking to yourself, oh, you don't even need to tell me this, McGrath. I know how to write the equation for a line. Yeah, it's y equals mx plus b, right? Right? Am I right? No, not right. I mean, it is, but that doesn't mean anything here. We don't want to be throwing down y's and x's when, I mean, look at this graph. There's no y or x anywhere in this graph. So those symbols don't mean anything. So here's what we're going to do. We're going to just name the things. If you look here, linear fit for data set, this little box is going to guide you through the process. It says f equals mx plus b, so it fixed this to an f. Because for the position here, I guess it didn't like my short name for position. Let's see what I did here. Let me go back and just check. I'm going to go back to my logger profile and back over. So I put, let's see, force, I put position, and so my short name, maybe if I had just said P, yeah, then it's going to be, so it'll only put it into the equation if you use a one-letter abbreviation. So that's fine, whatever, I don't really care about that. The X is fine here, so long as I don't put an X in my equation down here. So I would like to make a nice version of this equation. It starts with force, F. If you would like to write out the whole word, force, you can do that. That's fine. I'm just going to do F equals. Notice in the equation here, the variable F does not get units attached to it because it's a variable. Now the slope, on the other hand, here, this is where the slope is going to go, is 4 pounds over centimeters. So I would like to put this in as an actual fraction. So I'm going to go here. You know what? I should have gone. I'm going to go here, insert, and I would like to insert a new equation. So you see where that came from? I clicked on insert, and then this popped up, new equation. There's all sorts of cool options here, including over here, where it says math operations. You can bring up your fraction bar. And I don't actually need that yet, so I'll do that. First, I need F equals, I need my fraction. Actually, no, I don't. Yeah, I do. Okay, so I'm going to do that, and then I'll go ahead and put the 4 pounds. And then on the bottom, it's centimeter. If you look at what it says here, 4 pounds over centimeters. I'm going to stick a 1 in front of the centimeters. Here in this equation, this version that Logger Pro is telling me, 4 pounds over centimeter. I want that number there because it's going to help me explain and understand what it means, what the slope means. And then what's the next thing in the equation? This says, it says X here, but really X is my position. So I'm going to say here, P, oops, it's not in the equation thing anymore. There we go. See if I can squeak my cursor in there. P, you could do a little, if you like, if it helps you to understand what's going on, you can do times P if you want, but they're right next to each other, so that's fine, with or without. and then plus 0 pounds. And now, if you're wondering, like you're thinking, well, why are you putting that there? It's 0. Because I just want to have an intercept there that I can see in my equation. All right, so there's my equation. Again, I want to point out the important features here. These are the variables. This is like the y right here, and this is like the I'm trying to just highlight the b. There we go. That's like the x there. This is the slope, not the 4. The 4 is not the slope. 4 pounds over 1 centimeter. That's the slope. The whole thing with the units. That's the slope, and this is the intercept. Notice that pounds over centimeters. What slope? It's rise over run, right? Look at this. Rise, pounds over run, centimeters. So whatever the number is for rise over run, it's going to have those units. Units of rise over units of run. Okay, what does this mean? Well, somebody asked you, what is the meaning of the slope? The meaning of the slope is, I'm going to read this from the bottom up. For every 1 centimeter of, let's say the spring is stretching, of stretch, the spring, you're stretching it, the spring is going to resists with 4 pounds of force. Now, if this was a real like lab report or whatever, you wouldn't have to say those exact words. The key things here are for every 1 centimeter here, let's see, where's my, I'm much more familiar working in Microsoft. I just want to underline that. That would be an easy thing to do. Well, let's just pretend I underlined that. So, oh, that's probably it there. There we go. Okay, so let me do that again. So for every 1 centimeter, I'm going to underline that. Those are the key phrases here. For every 1 centimeter, here I said of stretch, the spring resists with 4 pounds of force. For every 1 centimeter, you get 4 pounds of force. That's the key. It's not okay to just say, what's the meaning of the slope? Oh, that's how many pounds you get for every centimeter. You need to include the number. Here, that number is 4. So for every 1 centimeter of stretch, you have 4 pounds of force. I think it's possible to say it the other way around. In other words, you could say, the spring, what's the meaning of the slope? This meaning is the spring resists with 4 pounds of force for every 1 centimeter that it gets stretched. Sure, that's okay. I would prefer if you got in the habit of reading slopes from the bottom up. For every 1 of these, you get, I don't know how many of the thing on the top, right? That's how I would like you to do it. What is the meaning of the y-intercept? Got it. What does that mean? Well, here's 0 pounds. Okay, so it's 0. So what does that mean? Here's a bad thing to say. The y-intercept is where it crosses the y-axis. Look, I speak English, and so do you, and so do the other people you're going to be talking about physics with. So actually, there are people who speak many languages who talk physics. And whatever language they say y-intercept in, we humans all know that y-intercept means where it crosses the y-axis. I mean, that's what y-intercept means. So that is profoundly not helpful to say that. What we need is what it means in context. So here, in the context of this, The y-intercept is how much of this you get, in other words, how much force or whatever's on your vertical axis you get when there's none of this. So let's see, what does that mean? It means that when there is no stretch, let's say zero stretch if you wanted to. When there is zero stretch, you could say when there are zero centimeters of stretch. Any of those is fine. There is no resisting force. Or there are 0 newtons. Pounds. There's 0 pounds of resisting force, or some version of that. So that's all great. What you can't do is you can't just say the y-intercept's 0. Well, no, that's not really saying enough in the context here. That very well may be true. There is, or you also can't say there is no y-intercept. There is a y-intercept. It's 0. It's still intercepting the y-axis here. So we want to say something very formulaic like this. And notice here that I'm doing for every, for 0 of this, it's how much of this there is. I'm going to do it that way every time. All right, so there's an example for you. Let's do one more. All right, let me ditch this one. And here's another one that I made. Position versus time, all looks good. It's real, super nice, clean data, not realistic, but it'll work for our purposes here. How's the graph look? Position versus time. There's position, time. It looks like we're measuring position in feet and time in seconds. Okay, so it looks nice and linear, so I'm going to go ahead and click that linear fit, and there it is. And I'm going to blow that up because it's easier to read for everybody. All right, and I'm going to put it in this corner down here. I mean, it doesn't look as good. Like, don't put it right on top of your line. I'm just clicking and dragging that around. Down here, that's fine. Up here, that's fine. Just try to put it off the graph. Okay, great. So I'm going to do the same thing. I'm going to go to my snipping tool and snip, snip. And click and drag over that. And then I'm going to go back to my Google Doc. Oops. And I'm going to bump down to the next page and insert, paste that. Okay, so there's my graph, looks good. And I would like to write the equation for this line. So here I've got my little equation tab. If that wasn't there, you'd go to insert equation. So you get that to come up. And my little equation box came up. Okay, so here position equals mt plus b. So position, that's good. You can write out the whole word position if you like. Position, I abbreviate it like that, is equal to, now my slope, I need a fraction, so I'm going to go to this math operations, bring up that fraction, and what do we have? -4 feet, -4 feet on the top, and then on the bottom, it just says seconds here, right here, but I'm going to put a 1 in front of that because it helps me understand the meaning of it. 1 second. And then I'm going to go off to the side here. I try to go off to the side and see if I'm still in here. And then put my, T right there. If you like, you can put a times T in there. Multiplication is implied. And then the intercept here, plus 3 feet. All right, that's my equation. If you're thinking y equals mx plus b, this is the y, this is the m with the units, that's part of the slope. Here's your x variable, the t, that doesn't have units, because it's a variable, just like this one didn't. And then there's your y-intercept, which does have units because it's a number, it's a quantity, it's an amount of stuff. All right, so what if somebody asked you, what's the meaning of the slope and what's the meaning of the y-intercept? Copy and paste that. Meaning of the slope, so this time for every 1 second of time, or you could just say for every, you could put time here if you like, or you could just say for every 1 second, that's fine. You could say for every 1 second that passes. There's no exactly right words here. The important thing is that for every 1 second. Now what could this be? This is like something that's moving. The position of it is changing. So let's just call it the object. The position of the object. And now let's see, the slope here, the slope is negative. So what does this negative sign mean? It means that the position is decreasing. The position is going from about 3 down to 0, and then into negative numbers. The position of the object decreases by 3, just kidding, by 4. Is that enough? No, you have to have the units by 4 feet. Okay, so the important things here are position, what's the shortcut for that? Control U. Let's use that instead. So the position decreases by 4 feet. Those are the important bits there. For every 1 second that passes, the position of the object decreases by 4 feet. If you're wondering, wait, how can the position of something decrease? Well, if you imagine something that's like on a number line, I mean, this could be a car on a road. Number lines can be like laid or superimposed onto all sorts of things that are straight lines. And in fact, Interstate 81 is like a big number line. It's got mile markers on it. So can the position of something decrease on Interstate 81? Yeah, I do that every morning when I get on at position 205 up in Rafine, where I live, and I come down to position 191, which is where the high school is. So sure, position of something can decrease. All right, so that's the meaning of the slope. Meaning of the y-intercept, when time is 0, or let's say this, let's say at time 0, the position is 3 feet. There's another maybe a little bit more intuitive, that's totally fine what I just said there, but there's another maybe more intuitive way of saying that. You could say, since time 0 is like the beginning of when we're paying attention, you could say the starting point is 3 feet. The starting, oh, I knew what I wanted to say. The starting point is 3 feet. So for me, the starting point in the morning is mile marker 205. That's my starting point. That's like when I leave. So here, in this case, whenever people clicked that button on the stopwatch and said, okay, ready, go, this thing was at 3 feet, and then it started to go toward more negative positions. The starting point is 3 feet. Okay, so that's a little bit of how to write the equation for a line in physics with all the right units and all that. And a little bit about talking about the meaning of the slope and the meaning of the y-intercept. We're going to be doing that an awful lot all year long. So this is very important stuff. All right, I'm going to find my little, let's see. Oh, there it is, my check mark. All right, bye.